Morning, students. Welcome to another session on predictive modeling. My name is Henry, and today we'll be talking about linear outcome 2, which is developed application of multinomial logistic regression and ordinal logistic regression. Yesterday, we looked at linear outcome 1, which is develop models using binary logistic regression and assess their performance. We looked at various types of logistic regression and all. The purpose of regression analysis, type of regression analysis, and then we looked at what linear regression is, logistic regression, among other things. So today we'll be looking at development application of multinomial logistic regression and ordinal logistic regression. So this is the indicative content. Multinomial and ordinal regression intrinsic ordering. Multinomial logistic regression, polytomous LR, multiclass LR. That's when you say LR, it means logistic regression. Softmax regression and multinomial logit, that's MLogit. The maximum entropy classifier, and the coordination maximum entropy model. Ordinal regression, ordered logit, and ordered probit. Use R or Python coding to create models. So these are the key terminology. So what are the multinomial logistic regression and ordinal logistic regression? So when dealing with categorical outcomes with more than two groups, researchers should consider applying multinomial or ordinal logistic regression. Multinomial logistic regression can be applied to either ordered or unordered outcomes, whereas ordinal logistic is only for ordered outcomes. So the next thing is, what is the difference between multinomial logistic regression and ordinal logistic regression? Multinomial logistic regression can be applied for multi-categorical outcomes, whereas ordinal variables should be preferentially analyzed using an ordinal logistic regression model. Besides, if the ordinal model does not meet the parallel regression assumption, the multinomial one will still be an alternative. Sorry about today, I've got flu or cold, so yeah, if you hear me like sneezing and all, my bad. So the next one is, what is the ordinal logistic regression? Ordinal logistic regression is a statistical analysis method that can be used to model the relationship between an ordinal response variable and one or more explanatory variables. An ordinal variable is a categorical variable for which there is a clear ordering at the category levels. So we have a video about what we've been talking about all morning to watch. So let me open it to one side. Give me a sec. Paste it here.
Anyways, and then
So it's a 17 minutes video. So we'll probably watch this at the end of the class, maybe like 5 or 10 minutes of the video after the session. So let me get back to the slides. We also have another video on ordinal regression, which you can paste here.
hi, my name is Hank.
It's also a 16-minute video. So we have multinomial logistic regression here, and then we have ordinal regression there. So yeah. Data science tools. The tool that is widely used by data analysts is R. So you might be asking yourself that what is R? R is an open source programming language and a software environment for statistical computing and graphics that is supported by the R Foundation for Statistical Computing. The R language is widely used amongst statisticians and data miners for developing statistical software and data analysis. So if you want to download R, you can just do download. Yeah, so this is it. can come here to download it. Yeah, that's where you download R from. This is for Windows. And also if you're using Mac, yeah, you can download this. You can download here for Mac. If you're using Ubuntu, excuse me. Yeah, this is the link to download the Ubuntu one. We also have R Studio. Yeah, excuse me. Yeah. So this website provides a detailed guideline on how to install both. And yeah. So why R? Data analysis and visualization. Apart from being one of the most dominant analytical tools, R also is one of the most popular tools used for data visualization. And also it can be used for programming and statistics language. Apart from being used as statistical language, it can also be used as a programming language for analytical purpose. So just for us to know more about what R is, we can have a look at it here on why and what we use R for.
Less expensive train tickets, more comfy coach.
Yeah, let's wait for the advert to finish.
That are.
Yeah, so this video will tell us why we use it or not. Yeah. Moving on, Python. Python is another programming language, which is an interpreter high-level programming language for general purpose programming. It has a design philosophy that notably uses significant white space, preferred from data science for its simplicity and high performance. So yeah, data scientists use Python because of its simplicity and high performance. So you can either use R or you can use Python. Yeah, which one is like easier for ease of learning? R has steep learning curve, difficult at the beginning. Python is preferred language as a beginner. How to walk through using code samples to create data science use cases. So basically, as a beginner, yeah, you might find it difficult like when you're learning R. And also, as a beginner, Python might be preferable because it is beginner friendly. So yeah, just choosing either one of them is up to you and what you want to use it for. The speed, R is a low programming language, while Python is a high-level programming language. And data handling capacity, R is convenient for analysis due to huge number of packages and ready usable tests. All the packages such as NumPy has improved from the latest versions. That is for R. So we have a package called NumPy, which has been improved since the last update. Like every version has been updated for use. And the graphics and visualization are easier and better for visualization and more effective than raw values. Python, complex and tedious, gives a tidy apple, amazing visualization packages. So you can but for both, you can obviously use any package that you want for both. We can literally, there's some packages in Python. It's a popular package for that we can use. Yeah, I know this website. Sure, yeah, so we have NumPy, we have Pandas, we have Matploit, Lib. So we have loads of packages that we can use for that. Moving on, deep learning support. Two new packages have been added to improve the performance. New to deep learning. Python works amazingly through the library. So obviously, you can install any library for Python if you want, to have a more efficient work and all. Flexibility. R is easy to use. Statistical tests and model are available to use. Python, flexible language when it comes to building websites and application. So we can use Python to build website. There's this popular framework called Django. Not Django Unchained, that's a movie, but Django framework, that's a Python uh, framework that you can use to develop websites. So if you want to like go into web development and you're looking for a programming language in Python to use, yeah, you can use this. And it's quite easy to use. They have like detailed documentation on how to like use it and how to like get started. I think is a MVC framework. Yeah, that's model, view, and controller. So you can use it. Yeah. So this is the model, this is the view, and then yeah, we have the templates. And I think we should have controller. Some, I don't know, can't remember. Yeah, but that's just it. So you can use it to like develop website if you want. Yeah. Moving on. Code repository and library are huge repository, more libraries. Python less library, more complex to install. NumPy, Matplotlib. So obviously, like Python has less library, and yeah, it's complex to install. That means that libraries such as NumPy like are really relatively difficult to install. And the popularity index, Python is more popular and R is less popular because, yeah, so basically, more people use Python for like anything they want to use it for, maybe like for web development or for like data science stuff. More people use Python than they use R. R is like less popular. That's why most people don't really know much about R. And job scenario, Python has slight edge over R due to the high demand and simplicity. So people prefer to use Python because first of all, the way of learning it, it's easier to learn Python like you saw in the previous slides. It's easier to learn Python and it is beginner friendly. And then yeah, it is highly demanded in the market than R. Community and customer support, they both have online community, but not customer support. So commands in R. So we have loads of commands in R. Obviously, like apart from using the slides, just for your reference when you're doing your assignment, you can, yeah, come have a look at this just to see the commands that is in R and how to use it. This is a good uh, article on how to use R and the commands and everything. We have plots and so on. We have variables, we have data types, we have operators, conditional statements, conditional statement, which is like if or else or something like that. Operators, which can be plus, minus, or anything. And variable, we should know what variable is. So if you don't know what variable is, um, yeah, so variable are containers for storing data values. So basically, we store values into variables. So take, for example, we have this. We have name, which is John, and age, which is 40. So the name has the value of John, and the age has the value of 40. We can also change this to Doe. If I change it to Doe, it's going to output, it should output Doe. Yeah, so name is Doe, and the age can also be 28. So yeah, so that's literally what variable means, and that's how we use variable. We have conditional statements. I think we should be able to look at this too. Yeah, so let me have a look at this. Give me a sec. Yeah, that is if else. So if else is conditional, you know. So we have conditions and if statements. So yeah. So let's try this. We have this, we have A, which is 33, and we have B, which is 200. So this is a conditional statement which we have here. So we can say, so in this statement, we have a condition and an operator. So we are doing two things together. We are doing variables. We are doing variables. We are doing operators, and we are doing conditional statements. So right here, so this is the variable, this is the condition, and this is the operator. So we say if B is greater than A, print B is greater than A. So that means that B is obviously 200 and A is 33. So that means that B is greater than A. So if we should do this, that means that B is not greater than A, so it's not going to print anything. It shouldn't print anything. It should just like, yeah, I think it's taking its time. Yeah, maybe the compiler is taking its time. Yeah, so we can't see anything on there. Yeah. So, but if we make B 100, for example, we should see the output again. Yeah, B is greater than A. Also, we can do this if A is greater than B. Right now, A is not greater than B, so we shouldn't see anything. Yeah, it's taking its time. Yeah. But if we should do this 330 and run it should print A is greater than B. A is greater than B. So that's what it means. We have loops, we have strings, and we have functions. So yeah, we have loops, which is for else or for each. We have the while loop, and then we have the for loop. So this is a while loop. So what are loops? Loops can execute a block of code as long as specified condition is reached. Loops are handy because they save time, reduce errors, and make code more readable. We have two types of loops. We have the while and the for loops. So this is an example of the while loop. And then obviously you can break it and everything. And then we have the for loop. Yeah, which is this. That means that for X in 1 to 10, print X. So that means I think it should be able to print between 1 to 10. I'm not sure what's going on with the website or the compiler. It's taking its time. Yeah, like I said, we're going to print 1 to 10. Moving on, we have strings and then we have functions. So how do we install R? For Windows, like I think I said it before, I gave you a link. So for Windows, you click here. So yes, let me bring this, copy this here, and then we should have it. Let me close this because I'm not using it anymore. Paste it. Yeah, so that's how you install R on your Windows. For Mac and Linux, I think I gave you an example of how, sorry, a website of where to install it. Yeah, so like I said, variables are nothing but reserved memory to store values. So you store values. This means that when you create a variable, you reserve some space in the memory. So we have X is equal to 15, Y is less than hello, true, and that's literally what variable is. And then we have data type. This is literally basically the explanation of everything that we've seen there. And obviously I've explained it, but we can go through it again. Data type in programming is classification that specifies which type of value a variable has and what type of mathematical relation or logical operations can be applied to it without causing an error. We have vector. Vector is a sequence of data elements of the same basic type. There are 5 atomic vectors, also termed as 5 classes of vectors. We have arrays. Yeah, arrays is not given here, but we can come here. Yeah, and just look at arrays. And then example of vectors are not given, so we can use this website. So arrays, compared to matrices, arrays can be more than 2 dimensions. We can use array. This is how you use it. Function to create an array and the dim parameter to specify the dimension. So this array, which is between 1 to 24, so an array with 1 dimension with values ranging from 1 to 24, or an array with more than 1 dimension. You understand? So that's how you do it. So yeah, you can use this website for more explanation. And also we have our vectors. Vector is simply a list of items that of the same type. So to combine the list of items, we use the C function and separate the item by comma. So obviously, like these are fruits. We have banana, apple, and orange. So it's going to print fruits. These are numbers. They're going to get us numbers from 1 to 10, and so on and so forth. Yeah. Evaluate the difference between multinomial and ordinal regression. Multinomial regression and ordinal regression are 2 types of regression analysis using statistical modeling to predict categorical outcomes. The main difference between the two is the type of outcome variable they are used to model. Give me a sec. Okay. Okay, I'm just trying to see if it's the right slide because I think we covered this yesterday. What's going on now? Let me just stop sharing the screen. Give me a sec. For where reason, I'm not sure why it's not making it big. I don't know. I can't even scroll around it. Let me just close it. Finish here. What's going on here now? Yeah, let's do this. What's going on? Wow. Can't even close it. Give me a sec. Now we are talking. Okay, now I think we are back now. Let me close this. Then we are back. Sorry for that. Yeah. We have multinomial regression, which is used to model a dependent variable that has 3 or more nominal or other categories. The goal of multinomial regression is to predict which category the dependent variable is likely to fall into based on a set of predictor variable. The predictor variable can be continuous, categorical, or a combination of both. Ordinal regression, on the other hand, is used to model a dependent variable that has 3 or more ordered categories. The categories are ranked in a particular order, and the goal of ordinal regression is to predict the relative ordering of the category based on a set of predictor variables. The predictor variable can also be continuous, categorical, or a combination of both. So what are the key differences? The key difference between the two is the nature of the outcome variable being modeled. In multinomial regression, the categories are nominal and unordered, while in ordinal regression, the categories are ordinal and ordered. So that's the key differences. This difference in the nature of the dependent variable being modeled leads to differences in the types of statistical models and techniques used for analysis. So discussion multinomial logistic regression with example. So this discussion an example. Logistic regression is designed for two-class problem modeling. The target is used using a binomial probability distribution function. The class label are mapped to 1 for the positive class or outcome and 0 for the negative class or outcome. The fit model predicts the probability that an example belongs to class 1. By default, logistic regression cannot be used for classification tasks that have more than 2 class labels, so-called multi-class classifications. So this is multinomial logistic regression, and then we have a chart, the probability A, probability C, and probability B. Imagine a dependent variable with M categories. So example, J is equal to 3 voting for Bush, Gore, or nada. Probability of person I choosing category J must add to 1.0. So this is the formula that you can use to do that. So yeah, discuss ordinal logistic regression with example. Ordinal logistic regression is used when there are 3 or more categories with a natural ordering to the levels, but the ranking of the levels do not necessarily mean the intervals between them are equal. I just forgot that I haven't been sharing my screen. Oh, wow. My bad. Let me go back. Oh, yeah. So we looked at evaluate the difference between multinomial and ordinal regression. We also looked at ordinal regression. I also look at the key differences between the two, and also discuss multinomial logistic regression with example. This is literally what we covered before. And then this is the chart I was talking about before I started sharing my screen again. Sorry about that. You have the probability A, probability C, and probability B. And lastly, this is literally where we are right now. So discuss ordinal logistic regression with example. Ordinal logistic regression is used when there are 3 or more categories with a natural ordering to the levels, but the ranking of the levels do not necessarily mean the intervals between them are equal. Example of ordinal response could be the effectiveness rating of a college course on a scale of 1 to 5, levels of flavors for hot wings, medical condition, good, stable, serious, or critical. Diseases can be graded on scales from least severe to most severe. Survey respondents choose answers on scale from strongly agree to strongly disagree. Students are graded on scales A to F. So that's a good example of ordinal logistic regression. And then develop models for nominal and ordinal scale dependent variable in R or Python. So we have nominal data. Nominal data is categorical data that may be divided into groups. But these groups lack any intrinsic hierarchy or order. Examples of nominal data include brand names, which is Coca-Cola, Pepsi, or Sprite. Variety of pizza toppings, we have pepperoni, mushroom, onions, and hair color, blonde, brown, black, etc. And then we have ordinal data, which is ordinal data, on the other hand, describe information that can be categorized and has a distinct order or ranking. Levels of education, we have high school, bachelor's, master's. Levels of work, satisfaction, we have extremely satisfied, neutral, unsatisfied, very unsatisfied. And star ratings, which is from 1 to 5, 1 star, 2 star, 3 star, 4 star, 5 star. A few examples of ordinal data. So we can use this in R or Python. Yeah. Understanding data types in pandas. The widely used Python open source library Panda is used for data analysis and manipulation. It has strong capabilities for dealing with structured data, including as data frames and series that can deal with tabular data and label rows and columns. Panda also provides several functions to read and write different file types. We have CSV, Parquet, database, etc. When you read a file using Panda, each column is assigned a data type based on the inference. Here are the data types Panda can possibly assign. We have numeric, which includes integers and float pointing numbers. Numeric data is typically used for quantitative analysis and mathematical operations. We have string. The data type is used to represent textual data such as names, address, and description. We have Boolean, which can be true or false. This data type can only have two possible values, true or false. Boolean data is often used for logical operation and filtering. We have datetime. Obviously, like, we should know what datetime is. The data type is used to represent dates and times. Panda has powerful tools for manipulating data. Categorical, this data type represents data that takes on a limited number of values. Categorical data is often used for grouping and aggregating data. Objects, lastly, the data type is catch-all for data that does not fit into the categories. It can include a variety of different data types such as lists, direct dictionaries, and other objects. Understanding data type in pandas, like we discussed previously, we have objects, like a string, and then this is the number type and the usage. We have int64, which is an integer. It is the number type is this and the integer numbers. That's the usage. We also have floats, which can be floating point numbers. We have boolean, which can be true or false values. Datetime values. Time delta, difference between two datetimes, and category, final list of text values. So that brings an end to our session for today. Yeah, but before we go, let's watch a video on what R is.
R is becoming such a popular and useful tool in data analysis and statistical analysis. I'm going to tell you why. Stay tuned. Now, the short answer is, this is one of the rare occasions when something that is free and open source is in fact better, and that this is, in my opinion, better than the expensive commercially available alternatives that are out there. And if you don't believe me, just look at the trends. There are masses of people moving from SPSS to R, from Stata to R, from SAS to R. I don't see anybody moving the other direction. Now, R is essentially a programming language, and you might find that fact a little bit intimidating or scary, but don't. And you'll see when I do the little demonstration at the end of the video that it's not difficult to use, that it's relatively intuitive, and you can learn it, and there's loads and loads of support out there if you need it. The importance of using code when you do data analysis is that your analysis is reproducible. Somebody else can see exactly how it is that you got to the answers that you got to. Added to that, you've got the ability to collaborate with other people, and they can look at what you've done and make suggestions or changes or identify mistakes in your analysis. And you can't do that with a point-and-click system. And the next reason why using code to do your analysis is important is that not only is your analysis reproducible, but it's also repeatable. In other words, if a year from now you've got additional data, let's say you had data for 2018 and in 2019 you've got double the data set, you want to rerun that analysis, you just run your code, and everything, your data cleaning, your data manipulation, and your analysis all gets repeated right there and then at the push of a button. Now, one of the most exciting things about R is because it's open source, you've got people all over the world writing packages, and packages are things that you can install and use that deal with very specific data analytic problems. And these are free, and there are literally thousands of them. Another big advantage of using R is that it has incredible data visualization and graphics capabilities. In fact, in that sense, it beats any other package hands down. It's a slam dunk, nothing comes close. Right, now I'm going to do a short demonstration just to show you that using a programming language to do analysis is not difficult, it's not scary, it's relatively simple. Okay, so watch this. Okay. So in this particular example, I have got a little data frame called friends. I click on that and we can see it over here. We've got some variables and some observations. I'm looking at age and height. Let's see what we can do with those. Basically, the way the coding works is you apply a function to an object. So in this case, the function might be the mean. We want to know the mean of age, which is the object, which is 23. We might want to know the median of the height. We can plot a histogram of the age, or plot age against height. And we might want to know if there is a statistically significant correlation between age and height. And as we can see in this particular case, there isn't. Right, so clearly writing code is not that scary at all. I mean, I haven't broken out into a sweat. You'll notice I don't have a tremor. I don't have a heart palpitation. I haven't fallen over dead. I've actually survived. It's not difficult. It's not scary. You can do it. Now, if you're interested in learning R, then why don't you subscribe to this channel, follow the videos. I'm going to start off by just talking you through how to install R, how to install RStudio, which is where you're going to write the code. And then we're going to go through everything, data analysis, data manipulation, data visualization, all the way up to machine learning and AI. Thanks for watching. Leave your comments and questions in the discussion section below.
So this brings an end to our class today. Don't forget to send us an email if you have any question at learnerwork@ukvarsity.co.uk. I hope to see you next weekend for Learning Outcome 3 and then on Sunday for the assignment discussion. Bye for now.